Welcome to Rational Science. I'm a little late, like 2 minutes late because I couldn't get the streaming going. Anyways, I'm back home, brought with me a cough that I've had like for a month. Can't get rid of it, can't shake it yet, but I guess it's getting better. Anyways, what do we do here? This is rational science. Why is it rational? Because we move objects around. We explain mechanisms. We do physical interpretations. You cannot do a physical interpretation without physical objects. That's what Mother Nature and Father Universe run out there every day. They move one atom or thingy, whatever, from one place to another. They move gases, they move planets, asteroids, etc. It's got to be things. And what does mathematical physics do? Well, it's not physics at all. What it is concepts, mathematical concepts, which they morph, which they reify, they concretize, whatever it's called, into physical objects. And then they move these concepts around thinking they're moving physical objects. And just about everybody out there does the same thing because they went to the same school. So when you went to school, they taught you about waves, they taught you about fields, mass, force, time. None of those words belong in physics. They have nothing to do with physics. Whenever you use the word energy, you're not talking about physics. You're talking about math. Okay? There is no physical object called energy, so it's irrational to say that you're going to transfer this concept any more than you can say you can transfer love or intelligence. That's the problem with mathematical physics, and that's why there's not a single mathematical physicist, so-called mathematical physicist, right? Theoretical physicist. Not one of them can explain a single phenomenon of nature at the micro or at the macro level. Okay? And we have all these dissident groups that I talked about last week. One of them is the electric universe. And they're in the same boat. They criticize the establishment, but they don't realize that essentially there's no difference between them. Okay? And so let me pick up where I left off last week and do a little summary of the electric universe. I think it's important because it's going to be an introduction that leads us into the subject of today, which is supersymmetric particles. Supersymmetry. What the hell is that? Okay, so here we have it. This is the electric universe, essentially the fatal problems they have. Summary. They invoke the quantum planetary model of the atom. And if you're going to use that model, you first have to explain the model. You have to show us that you can defend that model. What is it? It's the little bead known as the electron bead. We're talking about the hydrogen atom here, right? The simplest atom. And it rolls around a bowling ball called the proton. And the question there is, why does it roll around? Why does it jump from energy levels or orbitals from one orbital to another? Falls to the orbital and then rises to the orbital. And in between, they either absorb or expel something called energy, waves or whatever. And so that whole model is bunk. It's garbage. Anyone who uses that model has to begin by justifying that model, defending that model. If you can't defend that model, you cannot proceed to the other stuff that the electric universe defends, among them ionization. How do you produce ionization? Why doesn't the electron leave of its own accord, spontaneously when it's rolling around? Why don't the planets leave the solar system? And nobody can explain that. They say it's gravity. Yeah, but you haven't explained anything. You're just using a word, a descriptive word, to refer to that phenomenon, that observation. And so ionization is, again, the loss of an electron bead. And you have electricity. It's a flow of charges. What is a charge? An electron bead. And they show it as a little ball, little tiny speck of dust that goes from atom to atom, all around the circuit. They even get rid of the atom, just have the little bead going around. Light, they use the electromagnetic wave or the photon, the little particle. And so both of them are irrational. Okay, the wave is irrational. There you have a little synthesis of it because it's made of two fields. Field is a mathematical concept. values at each point in space. That's all that means, the word field. It also has the fields are made out of vectors, which are also magnitude and direction. That's what a vector is defined as. In other words, we're talking about numbers. So you can't say that a wave waves, because a wave is a bunch of numbers made out of fields, made out of vectors. Plasma, not a thing. Okay? None of these three, electricity, light, or plasma, are things. They are dynamic concepts. Okay? And that's when the electric universalists say, oh, you're doing semantics, you're doing word wizardry, word salad, whatever. No, you have to do the word salad if you're going to make yourself understood by a rational audience. Primarily, you have to know the difference between an object and a concept, and these people don't. They don't realize that plasma, light, and electricity, all three of them are, light being waves, right, are dynamic concepts. And they are, the wave is a mathematical concept made of concepts also, and electricity and plasma are dynamic concepts. They are not things. You cannot point to electricity in a single frame. You cannot point to plasma in a single frame of the universal movie, because plasma is defined as ionization, which is a process, and electricity is also a process. So you cannot use these words as things. You can use a thing such as a tree. You can use the word rock, because they are not moving. You can move them later on, but you can point to them in a static scenario. You can't do that with electricity or plasma. Cosmic filaments, they say they're made out of electricity. That electricity, electrons flow through those cosmic filaments. They say they are conductors that bind or at least connect in some way all the stars and therefore all the galaxies. Absolute nonsense, poppycock. It has no place in science. Okay, we'll see that in a second here. Gravity, they say positive attracts negative because they think it's electricity. It's different charges. One is negative charge, the other one is positive charge. Has anyone ever defined the word positive or negative in physical terms? Absolutely not. These are just mathematical concepts or just labels. They say that one's black and this one's white, and black attracts white. That's all they're saying. And black repels black. Why does black repel black? Well, we don't know. We don't have a physical interpretation for that, for that observation that we see between magnets or whatever. Okay, but the worst offender in what we're going to be talking about today is that they assume that space is a physical object. Now, there's two versions. One is that space is itself a physical object, a finite physical object, right? Some of them say it even worse. They say it's an infinite physical object when all physical objects are finite. The definition of object is finite. So you cannot say that space, if it's a physical object, that it's infinite. Okay, it's irrational. But either space is a thing in of itself, or it is filled to the brim, to every little space, by something. And if it's not atoms, it's fields, or in the case of the establishment, they have these virtual particles, which are just numbers. So they have all this stuff filled with, all this space filled with objects. So they never defined the word space. We don't know what space is because they never defined the term. That's the problem. And they just casually, treat it as a physical object, whenever it's especially in their interest. And the electric universe is famous for that just as much as the establishment. They say they aren't, but they are. They're in the same boat. Okay, they treat it as a physical object. They must treat it as a physical object. Sometimes they use the word ether to refer to it. And again, they have to specify whether space is the same thing as the ether, or ether is something that occupies space. You got to tell me what ether is. The notion we've always had is there are little grains of sand that are moving, that are vibrating, meaning each grain of sand has to have a backdrop, which we call space. So you still have to define space. Let's get rid of all the ether, all the particles, everything in the universe, every atom. What remains behind? We call it space. What is space? What is that black stuff we see there between the Earth and the Moon, or between galaxies? That's what you got to define. And until you define the word space, you cannot begin to do physics. One of the most important words that we need in physics, to do physics. And here we have an example. Some of you are familiar with Sabine Hassenfelder, and she's going to tell us exactly what space is. Okay, so listen to her. I mean, if she doesn't know, who does, right? And here it is. Listen to her.
What really is empty space? Vacuum is what's left from a volume if you remove all particles. It's the absence of particles, pure space. Even empty space isn't really empty. That it contains something called vacuum fluctuations or zero-point energy.
So did you get an idea of what space is? Yeah, space is what she says, it's filled with something, with garbage or whatever. If you remove all the garbage, she says you end up with vacuum. Great. And so space is the same thing as vacuum. In other words, both vacuum and space are vacuum and space without the garbage that's in there, without matter. So what have we learned? We just learned that space is a synonym of vacuum. That's all we've learned. We don't know, we don't have a definition for the word. Or, you know, they can't point and say that's space, meaning it's a physical object, it's got a finiteness, it's got a border, it's got a, you know, surface. One of the two, it's got to be that, or either you point to space and say that's space and it's surrounded by, I don't know, intelligence or whatever, 10th dimension, or you define the term. That's how it is. And so, yeah, they don't have an idea to this day. After 10,000 years, they don't have an idea what space is. And they treat it like a physical object. That's where the problem is. We showed the other day that, you know, we have these different pressures out there, or vacuums, you could say. And on the moon, it was measured at minus 12 torr level by those people who believe we went to the moon, right? NASA measured it at 10 to the minus 12 torr. Okay, so it's you know, here on Earth, the best I've ever seen, you know, in a semiconductor environment where we do sputtering, minus 7 torr range. Minus 12, we've never even remotely dreamed of having. I wish we would have been able to function at that level. But minus 12 means there's very little particles. You can't run an electricity at that level. You can't run a current, you know, electron flow or whatever they want to call it. You can't run it at minus 12 level. There's simply not enough matter to run a current at that level. And if you go to interplanetary, interstellar, intergalactic, well, you can see how it continues to rise, the vacuum level. Now these numbers are not ground in stone. You'll see all kinds of numbers out there, and they'll say how many particles really are per meter cube or centimeter cube. I wouldn't put too much faith on any of those, okay? But the point is, as you get farther out into space, like between two galaxies, you're going to find very little material, very little matter, very few atoms, and what you're going to end up with is pure vacuum and space, whatever that is, right? So there's going to be more space than vacuum, than particles than matter, meaning that I think it's clear that there's a different level of vacuum, a difference in how much space there is with respect to matter per volume, per cubic meter or volume of space. Okay, so if we could take a volume of space, whatever that is, right? Cubic meter, cubic centimeter, whatever you want to use, right? It doesn't matter. If we look in there, we see so many particles. We measure that and we say, well, this is 10 to the minus 3. We remove some particles, now we get 10 to the minus 7. You remove more particles, whatever's in there, right? Now you get minus 12, minus 16, minus 19, whatever. The higher you go into vacuum level, it means the fewer particles, the fewer garbage you have in that volume of space. So what do we have more of? Space. So space does have a difference. You know, it's not the same thing of looking at a volume of space that has 10 to the minus 3 versus one that has 10 to the minus 12. Okay, you can't have the same amount of matter in one and the other. There has to be a difference. And so space is something different than the matter or the energy fields, whatever they want to call it, that occupy it. You know, virtual particles, they always filled it with something. because they're trying to determine what space is through an experiment. They say, well, we can't remove all the space, so every bit of space is always covered, always has some amount of matter, and if it doesn't have matter, it has fields. What are fields? Numbers. So space is full of numbers. That's what it is. Okay, so if the amount of space that we have out there without matter is what we call empty space. What is this empty space? We have to define it or find out what it is, if it's a physical object or not. And here you have the solar wind, right? And it reaches all the way to the interstellar space, you could say, right? And then solar wind is made out of magnetic field of the sun, and also of particles like electrons and ions that flow out of the sun and also help build this wall that protects the whole solar system. Here's another version of that. Let's see if I can show it here. Okay, and you can see that we have this sheath covering the solar system. And the question is, if we have this sheath, obviously we have some protection. What people don't understand is that sheath there, anything that you see there, is a 10 to the minus 12 torr, approximately. That's what the solar wind has been measured to, 10 to the minus 12, even to 10 to the minus 13 range. There's more vacuum in the solar wind than you have on the surface of the moon. Surface of the moon, the average would be maybe 10 to the minus 12, and the solar wind is in that range as well. So there are not enough particles to carry out electricity, for example. You need matter to conduct electricity. And so what's the issue? The issue is that under the electric universe and also the establishment, this is the version of electricity. It's electrons flowing from atom to atom. That's the version of electricity that everybody gets taught in high school or technical school or physics or chemistry or whatever classes they teach that in. Okay, what's the problem? Well, we have a couple problems. The first one is, if I can get this, give me a second here. There it is. Made it a little too big. The first problem is that they need this planetary atom. Okay? Otherwise, you cannot have that kind of electricity with the electrons flowing from atom to atom. You need this type of atom, meaning that the electron is a little bead that orbits or is somewhere around the proton. Okay? That's the first problem. You got to justify that atom before you can move on to telling me what electricity is. So anyone who believes that electricity is the flow of electron beads from atom to atom has to start with the atom, not with electricity. Okay? We're not done with the atom yet. Okay? So that's the issue there. The second problem is here, okay? And that is that they get rid of the atom altogether. And this is both the establishment and people like the electric universe. And what they do, they have the electron beads traveling through the vacuum. Okay? So they forget about the atoms. They say, oh, we don't need atoms. We can do it without them. We'll just flow the electron beads through there, through the vacuum. And this is absolute nonsense because, again, you need atoms to make conductors. You can't have conduction without atoms. And the electricians understand that more or less because, they deal with wires and so on. They know that electricity has to flow through a wire. That's what the establishment understands. The establishment has a different version. And, both sides kind of picked up on that and said, well, we can have electron flows through the air, through the vacuum, right, of electron beads. That's it. And here are some answers. I asked the question and found the answers in a single article of the Stack Exchange. Okay, and so here's the question. Okay, can electricity flow through the vacuum? Okay, and I got answers in one article, and the article has never been updated since 2015. That's 10 years ago. That means that all these people essentially believe in the same thing today. Okay? Nobody's updated it. And here it is. These are some of the answers I got. Okay, when an electric field is applied across a conductor, we get a current density due to the internal charge flow. The vacuum is not a conductor. Okay, this fellow says it's not a conductor. Okay, resistance of the vacuum is in fact infinite. In other words, vacuum is an insulator, right? It isolates electricity from continuing. That's what they're saying. Okay, it is an insulator. There are no charge carriers. You need free electrons in a material to conduct, and the vacuum doesn't have any. Okay, now keep that version in mind. Now you're going to hear different versions from all these experts. These are all experts, by the way. And here's this other fellow says, vacuum itself is a perfect conductor. Very high voltages are required to shoot electrons through the vacuum. Okay, this is what they believe in. The vacuum still is a conductor because it allows the flow of current. Okay, if the basic sense of a conductor is that it allows current to flow, then it is a conductor indeed. Okay. Another fellow says, answers him, I guess, says, electricity is the flow of electrons. Again, they have these electron beads in their mind, right? Electrons can flow across a vacuum. Okay. So remember, the vacuum is not a tube, right? But what they have is this notion that there's nothing stopping it. And that's more or less what this fellow is going to say. Over a long range, you need a force to get the electrons to travel across the vacuum. So you need a big gun, right, for those bullets to travel through nothing, right? That's what he's saying. And since there's nothing there, there's nothing to stop the bullet. Okay, so that's more or less the notion. They don't have any molecules out there that can stop the flow of bullets, okay, electron bullets. In a CRT, the cathode is heated, which gives the electrons the energy. Energy, what is that? They need to escape the cathode, okay? A large electric field then accelerates the free electrons across the vacuum and onto a target, okay, the screen. Yeah, fields cannot do anything and energy cannot do anything, and that's where these people run into trouble. They're bringing energy and field as physical objects. And so they say the energy pushes it out, and the field helps carry the electron to its target. No, energy and field cannot do anything because they are mathematical concepts and don't belong in physics. Physics is about physical interpretations, and that's what we're trying to give here, a physical interpretation. And so if these people are saying that we're going to do it with energy and field, they're irrational individuals. You can't use those terms in physics. Okay, those are mathematical terms exclusively. Okay, another fellow says the potential difference of energy or voltage, right, between the two electrodes must be large enough that the electrons can leap between them. Again, we have vacuum. They're going to have the electron leap across the vacuum. Okay, that's what he's saying. They need to leap because the vacuum is a perfect insulator. So we have people who say it's a conductor, people who say it's an insulator. And so there is no medium in which they can flow, like through a metal conductor. Right? This guy must have been an electrician because he thinks like an electrician would. You know, you need a physical object, a wire or something for the electrons to go through because, again, he's thinking that the electron jumps from atom to atom. That's what he was taught, and that's what he repeats. And Bohr's model, planetary model. But then again, we go back to the atom. Is the atom a little bead that rolls around the nucleus? Okay, that needs to be settled. Another fellow, he says, can we really say that vacuum is a good conductor of electricity? No, because vacuum is not a material object. Again, must have been an electrician. The word conductor was meant for material bodies. Vacuum is a lack of matter, right? That's not what vacuum is, but that's how these people define it, the lack of atoms, right? Or whatever. Conducting is associated with influence of the conductor on the medium of the conductee, which vacuum does not have. Okay, so we have these two versions, one that it's a conductor, one that it's an insulator, right? Which one is it? Will the real vacuum stand up? What the vacuum does is to allow matter to pass through it. Okay, matter can carry charge. Yeah, charge, no, we don't carry charge because charge is a number. We don't carry numbers in physics. Moving charge is electricity. Again, they're thinking of charge, they're thinking of little beads, electron beads. We need to see your atom. Okay, but it's ultimate, not the charge that transports energy. It's transporting energy. I guess on the back, right? Energy is a bunch of numbers. That's what it is. It's the electromagnetic field that is linked to it. Again, field, energy, charges. That's the language of these irrational individuals. The field can transport energy without the need of charges, but the latter is usually not called electricity. Okay, so he's got a different version of electricity. As always, they don't say what electricity is, they tell you what it ain't. Okay, that's not electricity. Oh, okay. And that's where it stops. Instead of telling us, this is electricity. And here's electricity is what electricians deal with. I like this version. Physicists are dealing with charges and electromagnetic fields, which are ultimately connected by quantum field theory. Okay? He is asking an electrician's question, and physicists can only give a physicist's answer. Now we have two types of physics. We have the ones done by electricians, and we have the ones done by physicists. So they each give you a different answer, and everybody's at peace. Everybody says, oh, that's okay, I'll live with both of them. The original question is about what physicists deal with, not about what electricians deal with. Okay, so it's like we have these two worlds, a world of electricians and physicists. Even though they're all physicists, they all deal with physical things. They all have different explanations for what they do, physical interpretation, and everybody's at peace. Nobody questions any of it. Okay, so conclusion. This is from the site, right? The Stack Exchange. A vacuum is the absence of atmosphere. This is the summary, right? It is a neutral force offering neither resistance nor conduciveness to proton-electron flow. The state of vacuum does not compare with the state of space. Okay, so I thought vacuum was same thing as space. Space without matter is space, meaning also vacuum. They're synonyms, but he says they're not compared with the state of space. Whatever he meant by that. Space is a physical measure of distance. That's what he thinks. It's a physical measure. They say, oh, we measure the emptiness, okay, and can be overcome by the optimal difference of potential. Yeah, in other words, they're saying there's two versions here. One is you have to have a very strong gun to shoot the bullets, right, or an energetic gun, So you shoot the bullets. And if you have fewer atoms or molecules in front of that bullet, there's very few things to stop it from going forward. And in that case, the vacuum is essentially nothing, right? Whatever nothing is, nothing stands in the way. It's free of matter. And electricity the electrons, right, can flow through the vacuum because there's nothing stopping them. That's one version. The other version is the vacuum has to be full of something, some matter, in order for the electricity to be able to, the electron beam to go from atom to atom all the way to the end, to the target. So is the vacuum full of stuff or is it empty of stuff? And we never get an answer to that question. Okay, so what does the AI, finally I had to ask the AI because it's, I guess, run by the mathematicians. So this answer is a mathematical answer, not a rational one. Okay, don't expect a rational one from the AI. And this is what it says. Can electricity flow in 10 to the minus 13 torr? Yes, electricity can flow in a vacuum of 10 to the minus 13 torr, although the mechanisms and properties of the flow are significantly different than in a conductive medium like a wire. Okay, I don't know what they mean by that. I mean, it doesn't matter. You can conduct in one place, you can conduct in the other place. You obviously don't need a wire if you're going to send electrons through the vacuum. So I don't know why they put that condition there. But here you have it. 10 to the minus 13 is a very high vacuum, meaning there are very few gas molecules present. Correct. An electron can travel relatively long distances without colliding with gas molecules. So this notion here is that there's no impediment for the electron to reach its target because there's nothing stopping it. That's the notion of vacuum that they're representing here. But what are they saying about electricity? They're saying, well, it's a bunch of electrons, and as long as you don't put any walls in front of it, it'll continue rolling. Okay? It says electrical conductivity is a true vacuum, in a true vacuum, is negligible. Why would it be negligible? It should be greater. You don't have anything stopping it. All the electrons should reach their target. Why would it be negligible? See, they don't explain the contradiction there. the presence of even a small number of charged particles, or the interaction with surfaces. There's no surfaces out there in space, right? We're not talking about a tube through which these electrons flow, can allow for electrical current to flow. While a true vacuum has extremely low conductivity, why? We should have greater conductivity because there's nothing stopping the electrons. If I shoot from my gun, every bullet should reach its target in a pure vacuum because there's nothing stopping it. And the less vacuum I have, the more pressure I have in there, the more atoms I have, fewer atoms should reach their target. So it should be the other way around. Why is it extreme low conductivity? They don't explain that. The presence of even a small number of ions, charged atoms, or electrons can allow for a small current to flow. Why a small current? It should be a great current. These charged particles can be generated by residual gas molecules. And again, you need molecules, in the vacuum in order to have conductivity. And so they have a contradiction. On the one hand, they say you need molecules there so that we can have the electron flow. But then if we have no molecules or atoms or anything in there, every electron coming out of the gun should reach its target. And so they have a contradiction they never resolve. That's the bottom line. Okay, but then the electric universe, especially them, right? They say, look, we have all these filaments out there, and the question is, what are these filaments? And the electric universe answers, well, that's electricity flowing from one star to another, from one galaxy to another. That's what they're saying. Okay, that's what they think that is. So, and they use as an analogy the plasma ball. Okay, they essentially say the universe is an enormous plasma ball. That's their notion, that it's just a big plasma ball, and all these filaments are like, in a plasma ball you get all that electricity. So let's illustrate that. Here it is. Okay, that's what a plasma ball is, and you can see all the filaments there. So they must be right? And what's the problem? Well, the problem is that there's no electricity outside of the plasma ball. In the case of the plasma ball, you have this glass enclosure, this balloon, right, that's enclosing the electricity. The electricity only goes just barely at the surface, right above in other words, right above the glass, or at the glass level. And it doesn't flow to another ball across the room or across the street, right? On the other hand, it's the magnetic field of that same ball which goes beyond the glass enclosure. So the glass enclosure contains the electricity. It does not contain the magnetic field that is being created by that same object, okay? And so we look up the plasma ball electricity, and here it says, is there electricity flowing outside the plasma ball? I asked the AI, right? Plasma balls are powered by a high-frequency, high-voltage power source inside the base. The glass sphere acts as a dielectric insulator, right, between the plasma inside and the outside world, creating a capacitive coupling. The high-frequency voltage creates an electric field that extends beyond the glass field, okay? But electricity creates a capacitive current that interacts with the glass. Okay, but then what you have, when you touch the ball, your body acts as a capacitor, allowing the small amount of current to flow from the ball to your body and then to the ground. The current is what? Very low, and the glass provides insulation. Yeah, so you cannot use the plasma ball as a analogy for the universe or for what happens between galaxies, because like it says there, the current is very low, okay? You don't have electricity coming out of the sun, right, and flowing to another star or throughout the galaxy. Doesn't happen. There is no electricity. What you have is a magnetic field. And here's the magnetic field, okay? Outside the ball, you will have this magnetic field as I illustrated it there. And here you have a better description of that. Let me get this one out of there. The magnetic field generated by a plasma ball extends beyond the glass globe, okay? And its strength diminishes with distance. Normal. We have that with any magnet, right? The field can be strong enough to induce currents in nearby objects and cause small sparks or tingling sensations, particularly when using conductive materials such as rings. The field's reach can extend a few feet or even some meters, right? Enough to potentially interfere with nearby electronic devices like cordless phones or Wi-Fi. Okay, so the magnetic field does extend beyond the plasma ball. The electricity does not to any extent. I mean, it's right there at the surface. That's it. There is no electricity flowing from one ball to another ball. That doesn't happen. Okay, but the magnetic field does extend. That's an important point because the electric universes, they believe that galaxies have all these electrons flowing from one galaxy to another, and I was nice and I left the atoms there, but really if you get rid of the red atom, the balls, right, the little blue balls are the only ones that are flowing according to these people. The electron beads are flowing through the vacuum, okay? But in order for that to happen, they have to have all these particles in the background, serving as atoms, because otherwise you cannot have conduction, right? Of electrons, right? Electron flows from one galaxy to another, or even from one star to another. That's irrational. And that's where the whole electric universe falls apart. The question is, how different is that from the establishment? The establishment, the mathematical establishment, they believe that those filaments are actually have to do with gravity and not with electricity or magnetism. And that's where we see eye to eye with the establishment. It has, those filaments have nothing to do at all with electricity or magnetism. And that's what the electric universe has to prove or show. Really what they have to do is explain it in a rational manner, and they will not be able to. They cannot show that from one star to another you have electricity flowing. Electrons flowing through the vacuum. Absolutely not. You can't. And again, from one star to another, you have interstellar, you could even have intergalactic vacuum. And you're talking about a vacuum that, even conceding that you have that you could create an electric flow, electricity there, it's certainly not going to be either strong or constant. Okay, it doesn't happen. So these people simply don't understand something as basic as what the vacuum is. Out there you have lots of vacuum, meaning very high vacuum, meaning you're talking about 10 to the 12th upwards. And you cannot really run a constant current, really no current at all in my experience, but you can't run a constant current, a strong current from one star to another. So, even if you can see that there's an electric flow between two stars, it's not enough to power the sun. Absolutely not, which is another theory that the electric universe proposes. So they fill in almost everything. Nothing survives at the electric universe. Now, where do we start with the rope model? Okay, and for that we have to show, the difference between the rope model of the atom and the atom that quantum and the electric universe propose. It's a very different type of atom. It's a rational atom versus the irrational model of quantum mechanics. And here's the difference between them. The rope atom is a membrane, a balloon that encapsulates a star. We call it the proton star. And in comparison, the quantum atom is just a little bead that's somewhere around the proton nucleus, because this is the basic quantum hydrogen atom, right? So we have a nucleus, which is just a proton, one bowling ball, and the electron bead, which is somewhere on the outskirts. And that electron bead just falls between those two circles, for some reason that nobody knows. And it goes back and forth, and again, we don't know why it doesn't fall all the way to the proton or spontaneously leave the atom altogether. So it is an irrational atom. Our atom is a physical atom. Okay, we have a membrane that encapsulates the proton star, and both of them are made from every rope, from every single atom in the universe, from every single atom in the universe that converges upon our target atom here. Okay, one thread goes through the center, becomes the proton star. The other thread moves around the ball, right, and weaves the ball of yarn that encapsulates the proton star. That's the model. Okay. Do you believe in the model? We don't care. We need that atom in order to explain, and that's the one we propose. These people propose an electron bead rolling around a ball, and they can't defend our atom. We can at least defend our atom. Okay. Now, the only issue really with the rope model is see and touch. Okay, and that's what a lot of people have problems with, because they're so used to see and touch that they say, well, how come we can't see them? How come we can't touch them? How come a rope can go through another rope? And this is what is the hang-up. Okay? They cannot understand that because we don't have that experience in our macro world, in our everyday world. And so until you come to grips with the fact that the ropes cannot be touched, cannot be seen, and they go through each other, and they are physical objects that go through each other, until you come to, you come to that conclusion and you accept it, then you'll never understand how this universe works in a rational way. And just in case, quantum mechanics also has superposition. Nobody questions that. We have action at a distance where you have entanglement. This particle affects that one with no mediator. Nobody says anything about that. Everybody says, oh, okay. It's just mathematical descriptions. We have no explanation for any of that. Mathematical physics has no explanation for that. And how do they do gravity? Well, they warp some four-dimensional number lines. They call it energy or fields or something like that. Yeah, so they don't have rational explanations. Okay, so here's the atom put into motion. You can see the one on the top is the standard model, right? You have the electron bead moving around and somehow expelling this stuff called energy or waves or fields or whatever. And what we have is two atoms, the 3D version, 2D version. They're pumping, they're expanding and contracting. By doing so, they torque the electromagnetic wave that interconnects them, and that happens between any two atoms in the universe. So our model is a little different than what is proposed out there. Okay, so that's the main point I want to make. Do you believe in our model? We don't care. Belief is for churches. Okay, and in science we only explain so that you understand the mechanism and every aspect of it. It's a comprehensive system, the rope model. And again, we don't care if you believe or not, because belief does not belong in science. You can choose whatever your theory is right for you in the privacy of your own home or in church and Sunday school, but not in science. Science, we only explain and understand. That's it. That's where science stops. What continues is known as religion. Okay, so here's the rope model of electricity. Okay, what it is merged atoms. And here we're using the hydrogen atom just to make it simple, okay? But you got to think of these as maybe iron or some other bigger atom that conducts electricity. But what we're showing here is the mechanism, and we're saying that these shells, these electron shells, these atoms are merged. They're screwed into each other, right? They're merged. They blend into each other. They form these long rows inside a magnet, inside a conducting wire, whatever, and they spin in situ. By doing so, they release some thread from both, probably from the electron shell and from the ropes that interconnect them. And these threads, the so-called lines of force that Faraday discovered, 150 years ago, these threads, they twirl around at 90 degrees to the direction of electricity. Electricity is the spinning of the electron shells, a whole line of them, and so we can measure that, right? We can see that they're twirling around, and electricity flows in one direction, and the magnetic field made of all these gazillions of threads go at 90 degrees to the flow of electricity. There is no flow, obviously. All these, we call them serpentines because they look like a little snake, and it's twirling in situ. So the electricity goes nowhere. Okay, and what it is simply we detect it at the ends. One is clockwise, and when you see it from the other end, it's counterclockwise. That better be. And that's the positive and negative that all these people have been talking about for over 100 years. Okay, so here we have the solar threads, okay, and you can see that electricity happens only within the star, okay. You can say that there's some what's called plasma, right? Ionization at the surface, that happens, yes. But electricity stops there, stops essentially at the surface or a little beyond the surface of the sun. There is no electricity, no electron flow, right, from the star, from the sun to the earth, for example, let alone to another star. But what you will see is an enormous magnetic field created by those electron shells that are spinning, right? They're all merged, they're spinning inside the sun. And that magnetic field, all these threads, they extend way beyond the Oort cloud, you know, all the way to the edge of, you know, where the sun meets, or the magnetic field or the solar wind meets interstellar space, okay? So the field extends way beyond the sun, the magnetic field. The electric field, electricity, is only within the sun, essentially, okay? So that's the model we're showing. We're saying that that's why a star like the sun has electricity within it, a little bit outside where there's plasma, you know, ionization going on, but it's the magnetic field which extends way, way far, very far away from the sun. And the same thing happens to a galaxy. Here's the galactic field. And I was kind there, I was too conservative. The magnetic field stretches way beyond the edge of a galaxy, sometimes all the way to another galaxy. Of course, where the two galaxies, the magnetic fields of the galaxies meet, it's very weak because you have very few threads so far away, unless the two galaxies are very close to each other. So that's our model for the galactic magnetic field, okay? And one of the things that can explain, two things really. One is the jets that they say come out of the so-called black hole in the center of a galaxy. Absolute poppycock, nonsense. There are no such things as black holes because they are zero-dimensional. They are just mathematical concepts. Here we have physical object. We're saying that the magnetic field of the galaxy goes through the center up, in this case, you know, just arbitrarily going upwards, northwards, and coming down to the sides, through the sides of the galaxy. By doing so, any star that is in a given region where there's a lot of threads coming down for whatever reason. Remember, the magnetic field of a galaxy is not completely uniform, just like the one coming out of the sun is not completely uniform. So in a region where there's a star that's being hit by very, very many electric threads, it's going to move a star around like you would see a charged object in the lab, rolling around in like spiraling around, you know, inside the magnetic field. And that's what's happening to the star. It's a magnetic phenomenon, not a gravitational phenomenon as stated by the establishment. And it's not an electric phenomena like, you know, the electric universe argues. No, it's a magnetic phenomenon. That's our version, okay? And you can see why the jets coming out of the center of the galaxy have nothing to do with black holes or with jets, whatever those are. They think it's a spring throwing particles outwards. So you have this black hole that should be absorbing everything, and somehow it spits all this stuff out. And they were able to reconcile those two notions, you know, I guess through Hawking radiation or who knows what. Okay, so what does a galaxy really look like if we had the eyes of God? Well, you have to think of it as a spider web, okay? A rotating spider web. What is it? That every atom of every star is connected to all other atoms of every other star. So you have this crisscrossing of threads and really ropes in this case, and that helps maintain the integrity of the galaxy, right? And if you superimpose on that the magnetic field, then obviously you see why a star cannot leave the galaxy. The only way that you can have a mixing of stars entering another galaxy if two galaxies somehow come in contact with each other and go through each other, and then you would have maybe something like that happen. but not normally. You know, the galaxy just rotates like a spider web. That's it, because all stars, all atoms in the stars are all connected to each other. Okay, that's the model that we're proposing. And so what are these famous filaments? Filaments, what are they? Let's find out. Okay, here we have an astronaut. He's falling to Earth, and every atom of his body, I didn't draw every atom, by the way, or every rope that connects every atom in his body to every atom of the Earth, but that's what I'm trying to exemplify here. Okay, so we have this astronaut. He's falling to Earth, and all the ropes, you know, at infinity, just to say, use that word, very far away, all the ropes come together, okay, and they form a single coaxial. As the astronaut falls to Earth, those same ropes which have been superimposed at infinity now suddenly, you know, fan out. And you can see why, because of that, we have an acceleration, because more and more ropes participate in this phenomenon. And we call that acceleration of gravity. Okay? That's what's happening with gravity. So we have an explanation for that. And here now you can see, yes, the filaments, okay? All stars in this case, right? All stars are connected to all other stars through these ropes that connect every atom from one star to every atom of another star. So those filaments are really the coaxial through which gazillions of stars come together and form, you know, that single white line that you see there. Okay, so that's our model, and we don't need mathematical concepts such as field or energy or mass to explain this. We need objects, and we're saying all these are objects. Mother Nature, Father Universe, they don't know what math is. They don't deal with math. They move atoms every day, every second of the day from one location to another. That's their job. They use objects. The whole universe is run with objects, with things. You can't run the universe without things. And these people are running it with concepts. They're saying, oh, it's the field over here, the energy over there, the wave over there. You know, they have all these concepts, the singularities and who knows what else. That's the problem. The problem is language, partly because they created this mathematical language, which they introduced into physics and called what they do physics. When they don't do physics, they do descriptions. Physics is explanations, mechanisms, you know, causes. And that's one issue. And the other one is that, you know, they, to this day, not a single mathematician can explain to you how this universe works at the micro or the macro level. Why can't they? Because they're using concepts which are founded on irrational objects. They have waves, which are irrational objects, not an object. It's a concept. But they think it's an object, and they say, oh, we're going to move the wave. And then they move the field. What is a field? Value at each point in space. That's what a field is. That's how it's defined. And they start shaking these fields. They say, oh, we're going to shake the field. We're going to make it vibrate. You know, we have these excited fields. And then they say, oh, they move the charges. So we have fields moving charges. We have number. If a field is a number and charge is a number, we have numbers pushing numbers. That's what we have. And so they don't have a physical interpretation for anything. They don't understand anything, but they keep doing their math, and they're saying, why don't we understand all this stuff? Why does it have any meaning? It's not called meaning. It's called physical interpretation. That's what we call it in physics. Okay, so we have the introduction now, a lengthy one, but it was needed to clarify what space is. But do we know what space is? Well, I pulled out a few headlines this week just to show you what these people are publishing. The question is, how is it that these people are allowed to publish this garbage, this nonsense, this poppycock has nothing to do with science, let alone with physics. And they're allowed to publish this stuff. There are peer reviewers who approve these things for publishing. And these are the version given to the public, but they come out of what is called the scientific literature, meaning that the guy was peer-reviewed and he was allowed to publish in some physics magazine run by the mathematicians who call themselves physicists. And then these guys translated for the public like saying, oh, look what the scientists discovered. And here you see some of the headlines. They're all laughable, okay? What astronomers just discovered between galaxies changes everything. Oh yeah, it changes everything. I like that. Tiny primordial black holes created in the Big Bang may have rapidly grown to supermassive sizes. Yeah, sure. Black holes, what are those? Singularities, what are those? Just infinite whatever. Infinity, things falling forever into this little hole, which is not a hole, and et cetera, et cetera. A ghost particle flew through Earth. It might have come from dark matter. I mean, these are ridiculous notions. They should never have made it to science, let alone to the public. They're written by crackpots. Scientists produce a particle of light that simultaneously accesses 37 different dimensions. Okay, so it depends on how many beers they had, in this case, I guess it's 37. Okay, space.com. Roman Space Telescope will use a century-old idea from Einstein to probe the nature of mysterious dark matter. What is dark matter? Well, it's all that stuff that they had to sprinkle on the outside of a galaxy to explain why the stars on the outside of a galaxy travel just as fast or faster than the ones on the inside, which is, in their mind, irrational. So the only way they can explain it is by throwing kilograms out there, and they say, oh, these kilograms are invisible. No kidding. I mean, kilograms is a concept, right? So yeah, when you deal with kilograms, you're going to end up with nonsense. Scientists claim they just discovered an ultramassive black hole heavier than any other we found. All they talk about is the biggest black hole, the smallest black hole, the oldest black hole, the youngest one, the farthest one, the closest one. Is this science? Is this what we're going to have the rest of eternity? Just black holes at different sizes? Another one, astronomers suggest that entire stars are being obscured by giant lampshades of dark matter. Oh man, all that dark stuff. Black or dark. I think these people are racist. That's what I really think, New study rejects Big Bang Theory. It says universe grew via cosmic energy bursts. Yeah, except that energy is cannot burst because it's a concept. Okay, energy is like what Dick Feynman said. He says, we have no idea what energy is. And everybody uses the word energy, but nobody knows what it is. And yeah, is it a physical object? Can you transfer it? Show me a picture. I want to see the picture of energy, okay, before you transfer it, okay? Okay, so here's a couple that are funny because they come out of such groups as the ones you just saw. One says, what shape is the universe? Good question. What shape is the universe if the universe is a physical object, right? 13 billion years ago in the beginning, right? It starts like the Bible. In the beginning, everything existed in one chunk of matter. Okay, not all so-called physicists, mathematical physicists agree with that. They have different versions, but this guy believes it's one chunk of matter. The Big Bang created the vast nothingness we have today, so we have a Big Bang creating nothing. I do that every day. Create nothing every day. Big Bang did the same thing 14 billion years ago. Okay. Most astrophysicists believe the cosmos is flat. Okay, there you see the flat zero curvature universe. That's our universe there, folks. It's a flat board. Okay? A 2D sketch of the 4D phenomenon is impossible to draw. No kidding. I mean, how do you illustrate a 4D object, let alone a 4D phenomenon happening, occurrence? Okay, space bends around anything with mass the way a trampoline sags under a drop ball. Okay, they have the ball on canvas on fishnet notion there, right? Black holes send out ripples of gravitational waves like pebbles in a cosmic pond. Okay, and gaps between galaxies stretch and contort over time. So they have these notions that you have all these galaxies far away from each other on a fishnet, and they weigh down the fishnet locally, I guess, and that local bending travels all the way to the other galaxy, and that's why the galaxies attract each other. But as you can see, because they're all unsynchronized, I don't know how one galaxy pulls on another galaxy from so far away, because galaxies are separated by quite a bit. And so if a galaxy bends space-time, weighs it down using Newtonian force, right? Weighs it down, how does it pull on another little boat, which is, or worse, it's really, what is it? What are these things called? I forget the name. But imagine a rowboat far away. Why would it, if this ocean is malleable, how does one boat pull on another boat? That's I was thinking of a buoy. That's what it was. You have this buoy just locally, right? It's bobbing up and down here. How does it affect this buoy that's 100 miles away? And so that's what they've never explained. They just say, oh, it bends space-time and that's gravity. So yeah, this notion is what they spread to the public, which is total garbage. It has nothing to do with reality or with what Father Universe runs out there every day. Here you have another one. Is the universe really infinite? Oh, he's going to explain. An astrophysicist is going to explain. There's physically absolutely zero way we will ever know how large the universe is. Yeah, no kidding. This is not a question of knowledge. It's a question of making an assumption so that we can follow your theory. So you have a theory in which you say that the universe is infinite or finite, whichever one you choose, we don't care. Then you have to illustrate if it's finite. And if it's infinite, you got to say, well, then it's not a physical object because no object is infinite. In other words, one of the two, or it has something on the outskirts that gives it shape, that serves as a backdrop, or it's infinite, in which case it's not a physical object, because you're not saying that an object is infinite. What you're saying is, if I travel, all the way to the edge of the universe, I'll never get there because there is no edge to the universe. And what you're saying is you're using an adjective called infinite to qualify what should be qualified with an adverb, meaning incessant. You're talking about incessant motion, not about, infinite universe, infinite object. Space is actually expanding, he says. Okay, so I thought space was a concept, nothing, that which doesn't have shape. That's our definition. And these people say that this thing that doesn't have shape, this word that doesn't have shape, this nothingness is expanding. Great. So see, whenever they need space as a physical object, they talk about expansion. Then that same guy goes to another conference that says, oh, by the way, space is not a physical object. It's nothing. It's a vacuum. If you remove all objects from it, you have absolutely nothing. You have vacuum. And so what is that? I mean, are these people saying that this nothingness expands? Again, it makes no sense because they're treating space as a balloon, as a physical object, as a container, and they're saying this container gets bigger every day. So what's on the outside of the container? And that's when they say, well, that's an irrational question. You're not allowed to ask that question. Okay? It says the nothingness of space doesn't really abide by the laws for matter and physical things. So is space a physical thing? How can it expand if it doesn't follow the laws of matter and physical things? We have a contradiction right there in that. It says the universe shape is what? Flat. Flat doesn't mean what? What does it mean? It means traveling forward without changing direction. In the universe, we'll never get back to where you started. No, that's not what flat means. Flat means that if your floor is flat, what you're really saying, ideally, right, is that it's there's no curvature to it, meaning that it's thin as a pancake, but thinner than that. It's you can't see it from the side. That's what flatness is. Flatness is what you have in plane geometry. That's flat, ideally, right? So flat only belongs to the world of two-dimensional objects, such as squares and so on. And you can't bring the word flat, because what these people again are doing is talking about flat, which is an adjective, and they're explaining flatness with an adverb. They're saying you're talking about motion, you're talking about traveling, changing directions, etc., right? And so they're explaining flatness with motion, with a dynamic explanation, dynamic objects or things that are moving. You don't explain a static concept such as flat with a dynamic one. And says the universe is most probably a four-dimensional sheet of paper. Yeah, no wonder they can't illustrate it, because they say, I try to illustrate it on my piece of paper, these 4 dimensions, and somehow I can't put it in there, I can't fit it in there. No kidding. Okay, so last article here, which is funny too, because you've heard of the 4 forces. I think I call them the four horses of the apocalypse, because they invented all these forces, right? And they say there's a push, pull, and maybe and perhaps. Okay, so here they have the fifth force of nature may have been discovered inside atoms. Oh my God, we have a fifth force. Forget about four. Now we got one more. Every action in physics is governed by what? Some kind of push or pull. We're done. That's it. That's the only types of physical contact we can imagine. You either push or you pull. Okay, those are the forces. In fact, I always tell people that when you have tension, it's not a force, okay? Because tension means nobody wins the tug of war. Push, pull are forces because they are things in motion. Tension is there's no motion, okay? The best notion of tension is a dumbbell. You have the two weights and a dumbbell between them. Does the dumbbell move in one direction or the other towards one of the balls? Absolutely not. It's always fixed. That's tension. Okay? That's the analogy for tension. But it says, as far as we know, these all fall into one or just four categories: electromagnetism, gravity, and two kinds of nuclear forces. What do you mean two kinds of nuclear force? I thought the weak force, there you said it, is a push force, and strong, the gluons, they're a pull force. They bring quarks together, right? So we still have two forces, push and pull. Where do they get these four forces, let alone the fifth one? Okay? So yeah, may the force go with you. Forget about forces. They talk about forces instead of talking about physical objects that mediate the force, right? Okay, so here we have the standard model. Okay, we've all seen that. Okay, it looks more or less like that. Some of you know it by heart, so I'm not going to dwell too much on that. And they weren't content with this. They said, first of all, they invented all these stupid particles that don't even belong there. Some are force carriers, meaning they're verbs, and the other ones are the ones that build the atoms, the matter, and so those are nouns. The ones on the top, the green ones there, are nouns. The ones on the bottom, the bluish ones, violet ones, those are verbs, because those are forces, okay? So keep that in mind, okay? This is important because people don't realize that these people are comparing apples and oranges, or worse, nouns and verbs. Okay, so they were not content with this. They had to invent supersymmetric particles. Now we have other types of particles that were brought in because they had to give these people something to do, the new generation. They say, well, what do we invent now? Everything's been invented. And someone says, oh, I got it. Why don't we say that they have different spins? So the bosons, they have different spins, and they give them a different name. And the fermions, they have a different spin. They give them a different name, okay? And so here you have the chart so you get an idea, okay? Supersymmetric particle, SUSY, right? Good old SUSY there. Predicts. They always predict that. No, in science we don't predict. We make an assumption. These people call it a prediction. It's not a prediction, it's an assumption. You're making an assumption in order to explain your theory, or whatever theory is founded upon that assumption. Every particle has a corresponding superpartner with a difference of half spin. That's an assumption. That's not a prediction. Extends the standard model of particle physics. A theoretical framework, again, it's an assumption and it's not a theoretical framework. Or you could say an assumption is a theoretical framework, but these people are talking about theory, which is an explanation, and assumption is a hypothesis. Hypothesis is only assumptions that you need to make in order to give a physical interpretation to your theory. Postulates a symmetry between bosons and fermions. Okay, the fermions, electron quarks, they have half spin, and the bosons have photons and the W's, the weak forces, right? Integer spin. And there you see it. The red ones correspond to the red ones. They had to create these same letters, but they put a little sign on top so that you would recognize them as a different type of particle. And they did the same thing with the fermions, where, you know, the green ones there that you can see on the right, they have the same letters, but they had to put a little line over them. Okay, so that's what they did. And for this, they win Nobel Prizes, I guess. Not yet, but they will if they happen to discover one, you know. So don't hold your breath. Okay? Okay, so what do we have? What is SUSY? Supersymmetric particles. Here we'll have a super duper British guy, I think, and he's going to explain to you what it is. So you don't take it from me, you take it from the horse's mouth. Here it is. Here it goes. Listen carefully.
Supersymmetry postulates that the standard model is incomplete. There are other particles we've never seen before. Each standard particle would have a super partner in the other category, such that there would be a new boson for each fermion and a new fermion for each boson. The fermions, electron, quarks, neutrinos, would each have a boson partner, selectron, squarks, neutrinos, while bosons, photon, gluon, Z, W, Higgs, would each have a fermion partner, photino, gluino, xeno, wino, Higgsino. Supersymmetry is the hypothetical symmetry between particles of matter and interaction.
So again, what these people are doing is confusing nouns with verbs. Some of them are force carriers, that's what they call them. In other words, they're the interaction itself. And they had to create a particle that serves as a mediator for the force for the interaction. So this is as irrational as it gets. You have a ball that represents motion. That's what it is. Those are the bozos. I'm sorry, it was the bosons. I call them bozos. The people who invented them. And then you have the fermions, and they are the ones that construct matter. Okay? So those are nouns, or treated as nouns. That's the notion that they're introducing here. They say these are nouns. These are things that build matter, which are things, nouns. And these other guys are the mediators of transactions, and we call them verbs. They're force carriers, and they represent them with a ball. So now they created the supersymmetric force carriers, supersymmetric verbs. That's what we have. Okay? So yes, a bunch of nonsense what comes out of the establishment. But they're looking for them. They say, oh, hopefully one day we'll discover some of these neutrinos or snowinos. The winos, okay? And so we have here, what's the difference between them? You see that it's the spin. The ones in red correspond or are opposite the other ones, whereas you have the squark and the leptons, and they are zero spin, whereas the other guys are half spin. So some are integers and some are not. And for the green ones, you see the same thing. You have the halves on the right-hand side, the winos, especially the binos. And on the left, you have the ones, okay? So all they did was change the spin. They say, hey, I know, I can get an O for this. I'll just say that they have different spins, and with that, I've got a new category of particles. That's what they did. That's it. And you say, well, two things. First of all, why did they have to create this nonsense? And second, what is this spin thingy that is different between them? Does it mean that like a top, it twirls around and the other guy spins in the opposite direction or upside down, or what is this? And so here's a super duper definition of spin so that you can take it to the bank with you today. Here it is, okay? Twirling top metaphor for electron spin. While electrons aren't thought to spin, they're frequently depicted as if they do. Yeah, in fact, you can see the depiction there, the illustration, and it shows you that this roundish arrow that goes around, and they're talking about spin, how you would spin a top. But that's what they later on deny and say, well, it's not spin. Spin is not spin like a top. We just illustrate it that way to confuse you. Okay, so why can't they illustrate it? Well, here it is. Electron spin theory describes the electron as a quantum particle instead of a simple sphere. So not only we have the electron, which is not a sphere either, okay? They don't know what an electron is, what it looks like. They've never seen one, okay? Even though the Swedes filmed one, right, a few years ago. They filmed one, they never got a Nobel Prize. And you say, well, why didn't they? I mean, filming an electron, that would have been, groundbreaking. And the question is, why did they ever allow that to be published at all? Why did it reach the public from these cranks from Sweden, okay? Anyway, it says physicists have not yet developed a visualization of physical reality that underlies spin. Yeah, they have no clue what spin is. They just used a word and they illustrated a spin, but then they say, oh, we have no idea what spin is. But they are able to describe, not explain, right? Describe spin mathematically and predict its behavior in lab experiments. What they are predicting, we are again predicting, astrology, however, is the magnetic properties of quantum particles, not their rotational motion. The key to understanding spin is to realize that whatever it really is, its physical manifestation is magnetism. Okay, so they're talking about magnets, and the question is, give me a second here. Thought I wiped myself out. Okay, so what is it? They have no idea what spin is. And so why did they need this stuff? Why did they have to create it? I mean, just to create more particles? Was it just, hey, we have nothing to do, why don't we create more particles? We'll just make them differ by spin. Okay, that's an idea to keep making money and creating a future for yourself, job security, right? But here it is. This is the reason they had to create it. They said, standard model can't explain relatively small mass of the Higgs. Okay, the Higgs boson, that's the one that gives mass to particles, however you want to interpret that. This ocean through which particles have to travel, for some particles is more difficult and therefore they have more mass, that's the idea, compared to other particles. SUSY, right, good little SUSY, offers a potential solution by introducing super partners that can cancel out the large contributions to the Higgs mass. Okay, that's why they had to create it. SUSY unifies quantum forces, electromagnetic, etc., right, at very high energies. Okay, so again, high mass, high energies, energy is mass, according to Einstein's equation, right? Light as supersymmetric particles, LSP, predicted to be stable and weakly interacting. Okay, and so SUSY is also a dark matter candidate. So we kill two birds with one stone with the SUSYs. We have, on the one hand, we can explain the Higgs, right? And on the other hand, we can explain dark matter. So it was a dual purpose kind of thing. But the problem that they encounter is, to this day, they have not discovered a single one of these particles. So they're very frustrated. They're discouraged because they can't find them. But I suspect that soon, they're very close to discovering at least one of these particles. And here it is, okay? And it's the wino. So yeah, I think pretty soon they'll discover the wino over there at the LHC, at CERN. Anyways, with that, I will see you next week. And hopefully you don't go crazy over the nonsense that comes out of mathematical physics. We'll see you then.